Alright, Catrice, here's a little video tutorial I made for you which teaches you how to calculate your max height and your V impact of an object that is shot off of a cliff in the form of a projectile motion problem. So for this problem, which I've already pre-done and double-checked to make sure that I'm not giving you wrong information, the cliff is 10 meters high, okay? And it's being shot out of a cannon at 20 meters per second at an angle of 30 degrees. So the first thing we're going to do is just visualize what happens when this object is shot off a cliff. It comes out of the cannon and it follows the path like this until it goes over the cliff and it explodes down here somewhere on the ground. And one of the things that you need to figure out is the max height, the maximum height that it gets off of the ground. Well, a way you need to do that is sort of just figure out, what would this problem be like if there were no cliff? If the cliff extended out this way, your max height could also be figured out by this distance right here plus this distance. So what you do is you need to realize what's happening with max height. The number one thing that you need to start out with is breaking this 20 meters per second, which is at an angle of 30 degrees, into its two components. You have an x component, which is this way, and you have a y component, which is this way. And the combination of the ball moving in this direction and this direction yields an overall path of an angle of 30 degrees. So to figure that out, you draw your triangle with all your components on it. So on this particular triangle, the hypotenuse would be 20 meters per second. All these are in meters per second. And we'll do the x component first. So knowing that this is at an angle of 30 degrees, which you just get from up here, you use SOHCAHTOA to find out that this x component is 17.32 meters per second. Now you can use SOHCAHTOA, but a trick that I like to use, if you want to use it, is you take the hypotenuse times the cosine of the angle to get the leg that it's directly attached to. So I do 20 cosine 30 to get 7.32. And for the y component, the opposite component, you do 20 sine 30, which gives you a y component of 10 meters per second. So the first thing that we're doing and we're dealing with is max height. So when you're talking about height, you're not really concerned about how the object is moving from left to right or in the x direction. You're only concerned with how it's moving up and down. So right now we're only going to concern ourselves with this 10 meters per second value because that is the up and down, or the y component, of this 20 meters per second velocity at this angle. So what you do then is you set up your big 10 variables. So in this case, you're used to delta x, but you do it with delta y. You do delta y, VO, which is your initial velocity, VF, your final velocity, your acceleration, and the time for all this to happen. And just look through all the data that you have and fill in the values that you know. Delta y is the distance that it goes up. Well, that turns out to be your max height. So you're not going to know that right off the bat. So you just put a dash to let yourself know that you don't know that. Your initial velocity you do know. That's the 10 meters per second y component of this value, this 20 meters per second value. So your initial velocity you can fill in as 10. Your final velocity you actually do know, because when it's at its max height, it is no longer moving in the y direction. It goes up, it stops, and then turns around. So being that it stops, you know that its final velocity at its max height is 0. Your acceleration in this case is going to be the acceleration due to gravity. Now you know that's 9.8, but you can't forget that this needs to be a negative 9.8. And the reason why it's negative 9.8 is because it's a negative acceleration. The acceleration due to gravity is doing nothing for the motion of the ball in the y direction except slowing it down. If gravity was repelling it and helping it speed up, then you would leave it as a positive 9.8. But the 9.8 meters per second squared is slowing down the ball. So you use it as a minus 9.8. And the t, the time it takes for that to happen, you do not know. So those are the two variables that you don't know. So you start to set up your equation, which uses some of these variables, and you start out with this classic one of delta y equals VOT plus 1/2 AT squared. Now you start to plug in your values, and you say, okay, delta y, I don't know that, equals VO, I do know that, T, I don't know that, plus 1/2 A, I do know that, minus 9.8, T, you don't know that again, squared. Well, this is a problem because you have an unknown variable delta y and you have an unknown variable t, which shows up here and in the form of t squared over here. So what you do is you just use the other equation that you're given, which is delta v equals at. Now delta v is vf, v final, minus vo, v initial, equals at. Well, you're in luck in this case because you know that vf is 0. You know that VO, V initial, is 10, equals A, which you know is minus 9.8, and then T. So now you're left with only one missing variable in one equation, so you can solve for T. And what you do is you just divide by 9.8, and 0 minus 10 just leaves a negative 10 over here. So 10 divided by 9.8 is going to be close to 1, but a little bit more than 1. And what it ends up being is T equals 1.02 seconds. Now what that means is that's how long it takes for the object to get shot out of the cannon and reach its max height. 1.02 seconds later, it's going to be at its max height. Not really that important, but that's what it means. So now that you have this T value, you can plug that back into here. Now when you plug that back in, it's delta y equals 10, 1.02, because that's a T, plus 1/2 minus 9.8 times 1.02 squared, because there's a t squared, and you plug in the t. And what that ends up giving you is delta y equals 5.1 meters. Now that gives you your max height from here, this dotted line. But what you have to realize is that's not your max height anymore. If he asks it for you the max height off of the initial surface, then you just leave it as 5.1. But if he asks it for you for the max